Okay, so today is Go Math Lesson 12.4, and we're talking about histograms. So this is kind of a confusing thing because a lot of people confuse these with bar graphs. And a bar graph and a histogram are two different things. So the big concept that we want to work with today, it's another way, like our frequency tables and our dot plots, to organize our data in something that's an easy snapshot to see, right? We want to see how big the bars are. The bigger the bar, the more data. It's a specific amount that we can measure. So if I'm looking at something, though, if I'm looking at a bar graph, I might see something like this, right? And each of these bars is separated, and each of them means something specific. But in a histogram, what I'm going to change is more of a range. So what I end up with is something like maybe between 0 and 10 goes here, between 11 and 20 would go here, 21 and 30 would go here. And then they are going to be chunked right next to each other. And typically they're a little they're colored or something like that so that I can differentiate between them. So the big concept is I'm going to have a chunk of data that I'm interpreting at any given time. So let's see what that looks like in your book. We're talking about ages of Best Actor winners from 1990 to 2009. So very quickly I can see here what is the age that is most likely to win Best Actor. The one that wins most often is between 40 and 49. So it's not specifically the age that's 40 or 49 itself. It could even be 45. But between 40 and 49, that's when they're most likely to win. Okay? So let's break this down. And we interpret it. You can see here we have frequency. You always have to label your graph. We have a title. And then we have a defining trait, the age, right? With the age, we have a range, 20 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 to 69. However we want to define that, it needs to be uniform. It needs to be the same chunk for each one. You'll also notice with a histogram, unlike a bar graph, typically, these are right next to each other. They're separated by color or by texture or something like that, right? So the height of the bar shows how many data values are in the interval. So what I have here is ages of Best Actor winners. We have only had one that's between 20 and 29. I go to the top of the bar and I go over, and it's 1. Okay? Top of the bar, 30 to 39. I see that we have 6 of them. So we can ask ourselves some questions. How many winners were between 20 and 29 years old? I go to the top, and I know that only 1. What other bar represents people under 40? That's the 30 to 39-year-olds. And how many winners were 30 to 39-year-olds? I go up to the top, and I come across, and I see that 6 of them were 30 to 39-year-olds. So again, interpreting our histograph, it's more about creating a chunk of data. So let's take a peek at one more. And I move over here. I have a frequency table. Sorry. Histogram shows, go away. There we go. Histogram shows hourly salaries. That's kind of hard to say, hourly salaries. To the nearest dollar of the employees of a small company use the histogram to solve the problem. So what I end up with is between $10 to $14 an hour. There's only 2 employees that make that. Between $40 and $44 an hour, there are 3 employees that make that. So what I want to do then is ask myself a specific question once I've organized my data. How many employees make less than $20 an hour? So I make my cutoff at $20 an hour. And now the question is, how many of them make less than 20? So if $20 an hour is the bottom here, everything below it counts. So I have 2 here, and I have 5 here. So how many employees make less than $20 an hour? Well, according to my histogram and checking my chunks of data, I can see that if my cutoff is 20, 7 employees make less than $20 per hour. Now, if I'm starting at this company, what am I most likely to be paid? If I just randomly grab an employee out of this company, I can easily see in a histogram, much like my dot plot or my frequency table, that if I randomly grab a person, most people, more people than any other salary, make between $25 and $29 an hour. So this can lead to some more misleading statements as you move forward. So again, our histogram, we're looking at chunks of data versus something like a bar graph or specific points of data like a frequency table. So anything that falls within the chunk of data that I've defined is going to fit into that graph. And then I make a bar and I find some way to separate it. Okay? So take your time. Make sure that all of your points line up. And again, once you've used a point and you've calculated it into your graph, make sure that you're crossing it out.